All right, welcome to our next lesson, proportional relationships. Proportional relationships are linear, but they are a special kind of linear. Let's check it out. Oops. So Scarlett is spending her summer afternoons as a junior lifeguard at a local pool. Each afternoon she works, she's paid $10 plus $2 per hour. In the evening, she is umpiring for a recreational softball league at a local community center. They pay her $4 for every hour she works. Let's put me down there. So we're on page 161 in your book. So we've got two situations. Let's check them out. We've got the junior lifeguard job. Junior lifeguard job pays $10. For some reason, she gets $10 just for showing up for work. And then she gets an additional $2 per hour. And then we have another job. That's the umpiring. Doesn't even look like a word. Umpiring. And for umpiring, she gets $4 for each hour she works, period. There's no extra fee or extra payment in there for anything. So we have two tables, and we're going to figure out how much she gets paid for each of these jobs. So if lifeguarding, we're going to start with 0 hours. Amazingly, she is paid $10 for those 0 hours of work. She shows up to work and boom, they give her $10. But then for the first hour, she only gets $2 more. So she'll be at $12. For the second hour, she's going to get another $2. That's going to put her at 14, and then 2 more. Does this look familiar, everybody? This should look very familiar. We know this is linear. There's our constant rate right there. Every time we increase 1 hour, she increases $2 for her money. So that's lifeguarding. For umpiring, she just gets $4 per hour. So if she doesn't work, she doesn't get any money. There's no upfront money for umpiring. But for the first hour, she gets $4. And for the second hour she works, she gets another $4. And for the third hour she works, she gets another $4. And so on and so forth. That would be 20. All right, everybody with me? Can everybody see that these are linear relationships because they have a constant rate of change? Which is this slide. So on problem number 3, they asked, do the earnings from either job have a constant rate of change? Hopefully, you know the answer is yes. You can't share your ideas with your partner because we're all alone, learning by ourselves. How sad. So yes, they have a constant rate. They both have a constant rate. Why is this important? Why are we constantly looking for that constant rate of change? It's because the constant rate of change means that it's a linear relationship. Linear relationship. And the linear relationship means that I can use y equals mx plus b. You can't use this formula unless you have a linear relationship. So that's why we're constantly looking for it. Is it a linear relationship? We need to know so we can use our formula. All right. So we want to write an equation that could be used to determine the amount of money, Y, that Scarlett would earn for X hours working at the pool. They defined our variables for us. Do you see that? If you're going to use X and Y in an equation, you must define your variables. So they're saying the money she's earning is going to be Y, and the hours she's working are going to be X. If I didn't give that to you, and I won't on the quiz, I would want you to write. Whoops, don't write it with that though. Oh, that's not working. I would want you to write Y is equal to total amount of money, money, and X is equal to the hours she worked. Try to get in the habit of doing this. It's really important. It's going to make you better at word problems, and you're going to lose points on the quiz if you do not do it. Let's get rid of that. Okay. So they want an equation. We said it was linear, so we're just going to use y equals mx plus b. For the lifeguard job, we said $2 per hour. That's our rate. So that's going to be m. So y equals 2 times x instead of m times x. The rate is 2. The $10 she gets paid up front, that's our Y-intercept, our starting condition. She's not going to lifeguard unless you pay her $10 just to walk up to the pool. So that's our equation, y equals 2x plus 10. Do you see how nice? Get used to using this, please. Identify the slope of the equation and explain its meaning in the problem situation. Do you see how this question keeps coming up over and over again? We really want you to understand how to do this. So the slope, which I'm going to use as m, is 2. Its meaning is that she earns $2 per hour. Slope is always a rate. It's always going to be something per something, something each something every something, always a rate. Okay, identify the y-intercept in the equation. The y-intercept is 10. And what is its meaning in the problem? She earns $10. When you're describing the meaning, make sure you put the units on. She earns $10 at the start of the job. The job. How nice for her. I don't earn $10 for not working. Any questions? No, I can't ask for questions. You're not here. It's hard to get used to that. Okay. What about the umpire job, though? So now we're looking at the umpire job. And the umpire job straight up pays her $4 for each hour she works. No extra money there. So let's see if we can write an equation for this one. So we want to write an equation that can be used to determine the amount of money y that Scarlett would earn for x hours. So same variable definitions. X is going to be equal to the number of hours. And y is going to be equal to the total amount of money she earns. Total amount of money. So again, we said it was linear. We have that constant rate, so it's a linear equation. So I can write y equals mx plus b to help me out here. The slope is the rate, and we said the rate is $4 per hour. So it's going to be y equals 4x plus b. What is the y-intercept for this situation? Well, since she doesn't earn any money up front, the y-intercept for this situation is 0. She does not earn any additional money. So my equation will be y equals 4x plus 0, but we should probably simplify that down to y equals 4x. All right, identify the slope and explain the meaning. This is kind of redundant. The slope is 4. The meaning is she earns $4 per hour. Identify the y-intercept. The y-intercept is 0, and it means she does not earn any money at the start. When time is 0, money is 0. All right, next slide. Okay, so we are going to graph the jobs. So let's make this job be the lifeguarding job. And let's make this job be the umpire job. Lifeguarding job, let's label our axes. Always label your axes. So this is hours. And this is total money. This is also hours and total money. Okay, so lifeguarding, she gets that $10 money up front, but then she doesn't earn as much, only $2 an hour. So she gets 1 hour, she's earning $12. You can use your table from the previous page for this. And then we're going to draw a line. And there we go. So that's our graph for the lifeguarding job. For the umpire job, she doesn't earn any money up front. So we're starting at 0, 0. 0 hours, 0 money. But then after 1 hour, she's earned $4 more money per hour. After 2, 8. After 3, 12, and so on. And then I can draw a line through those points. You should be using a straight edge every time you graph a line. Please, please, please. Okay, there are my 2 graphs. So you can clearly see, hopefully, this line is steeper. The umpire job has a steeper line because the slope is greater. The slope of this line is 4, right? This line is not as steep, less steep. Because the slope of this line is a smaller number. The slope is 2. This line starts at 0, 0. This line starts at 0, 10. So this has a y-intercept of 0, and this has a y-intercept of 10. Everybody got this? All right. So the thing we want to learn about today is directly proportional or direct variation. Direct variation isn't used that much, so we're going to stick with directly proportional, and we can even drop the word directly, and we can just call these proportional relationships. Proportional relationships. Or you could say directly proportional relationships, but we'll just stick with proportional. So, if changing one variable in an equation by a factor causes the other variable to change by the same factor, we say the 2 variables are directly proportional or proportional and call the equation relating the 2 variables a direct variation equation. Direct variation relationships describe many real-life situations. So here, a direct variation is a relationship between 2 variables, x and y, that can be written. Here's the math one. This is kind of a wordy definition. This is our mathy definition. If it's written in this form, y equals kx, it is a proportional relationship. Okay? All proportional relationships are linear. So if I ask you, is this relationship proportional? The first thing you want to know is it linear? If it's not linear, then it's not proportional. It doesn't matter about anything else. Because look at this equation. Y equals kx. You used this equation last year when you were doing proportions. I don't know if you remember. But it looks really similar to y equals mx plus b. Agreed? Yeah, they're almost the same. The only difference is, let's see, instead of m multiplied times x, we have k. And don't ask me why they're using a different variable. I don't know. They mean exactly the same thing. K is the rate, m is the rate, m is the slope, k would be the slope. So they mean the exact same thing. The other difference I notice is if it's directly proportional, it doesn't have that second term. And if that term is missing, it doesn't mean that there is no y-intercept. It means that the y-intercept is 0. You got that? So this was the equation you used last year because you never talked about y-intercepts last year. But now that we're smarter, we know that the reason it was just y equals kx, it's because the y-intercept was 0. So, number 1, if it's a proportional relationship, it must be linear. Number 2, if it's a proportional relationship, it must have a y-intercept of 0. That's it. If it meets these two criteria, it is a proportional relationship. So all proportional relationships are linear. They have to be linear. So these are types of lines, but they're special types of lines because if we double, or if we multiply the input by some factor, the output is going to change by the same factor. If it's directly proportional or proportional, we can just divide y by x to get the slope. You can't do that if there's a y-intercept. So let's look at this next slide here. So these are the two graphs we came up with for Scarlett, and these are the two equations we came up with for Scarlett. One of them is proportional. Can you spot it? Yeah, it's this guy. This is our proportional or directly proportional relationship. Look at the equation. Does that not look like y equals kx to you, where k is 4? Yeah. Look at the y-intercept. Is it 0? Yes, the y-intercept is 0. Look at the line. Is it straight? Yes. This is a linear graph. This is not proportional. It is a straight line, which is great, but it does not go through 0, 0. Let's look at our other criteria. The other criteria was if you multiply the input by 2, the output would be multiplied by 2. So here, my input is 4, right? If I multiply 4 times 2, I'm going to get 8. So if I multiply the input of x, let's put in a table. So here's x and here's y. When the input is 1, the output is 4. What if I multiply 1 times 2? I multiply the input times 2, and I multiply the output times 2. Is that a point on my line? Well, 1 times 2 is 2, and 4 times 2 is 8. 2, 8 is a point on my line. So if I double the input, I will double the output. Let's look at the lifeguarding job. 10, oops. Interesting. I can't undo. All right, 0, 10. What if I double the input and I double the output? So if I multiply x times 2 and I multiply y times 2, well, 0 is maybe a bad example because here, actually it would still work. I'd have 0, 0, and I'd multiply times 2 and I'd get 0, 0. So 0 times 2 is 0 and 10 times 2 is 20. Doesn't work. Let's pick a different point. 1, 12. 1 times 2 is 2. 12 times 2 is 24. 2, 24 is not a point on this line. Does everybody see that? So proportional relationships have the form y equals kx. They are linear. They have a y-intercept of 0. And if I double the input and double the output, if I start at a point, I can multiply times any factor and I'll find another point. Non-proportional relationships, they have a y-intercept that is not 0. If you double the input, you will not get double the output.